I just started the recording.
Yeah, so I can quickly start just to set the stage. This meeting focuses on the review of the design of the Ownable State work, which is a big chapter in that's slated for 1.2, and it's quite a lot of work there, and it needs to. We will explain what it is about, and we'll also highlight the links to other pieces of work, such as the identity mixer, collections, and local collections. The presentation will focus on four main aspects. First, we'll introduce what Ownable State is in general. Then we'll focus on the privacy-preserving part of Ownable State. Next, we'll just quickly, briefly describe the relationship that this work has with collections in general and local collections in particular. There were some discussions on the last design review on collections, so we thought it appropriate to sort of revisit that bit. And then finally, we'll just see how it all works together and what's the value proposition behind. Matthias will present the first part, and I'll focus on the second one. So Matthias, take it away.
Okay. Hi, everyone. Thanks, Ali, for the introduction. So let's get started. So what is Ownable State to begin with? So essentially, Ownable State is a ledger subspace that has designated owners. And the ledger subspace, think of, say, for example, a namespace is defined using composite keys. And this ledger subspace has its own endorsement policy. So it's much finer grained than a chain code level endorsement policy, in that you have an endorsement policy per subspace. And each of these subspaces can hold multiple data values in the sense of a ledger key, a KVS key. The flapping noise is really irritating.
Yeah, if you're not speaking, try to go on mute, and maybe this thing will disappear.
Okay, I'll try to focus on it less. So on the right-hand side in the picture, you have an example. So you have the overall chain code namespace. Think of the key value store namespace. And then you would have certain subspaces in that whole namespace, in the KVS namespace. And these subspaces would have a certain Ownable State identifier, so they are separated from one another, and they have certain owners. And those owners are essentially can be various organizations of the network. So it could, for example, be organization A and organization B. And in general, if you want to do an update on an Ownable State, then you require an endorsement by the owners that own that Ownable State. So this is the main idea behind it. So let's have a look at how this is essentially represented on the ledger. So we have the root chain code namespace, and under the chain code namespace we have our various key value store entries. Could, for example, be a key that is named foo with some value and a key that is named bar with some value. So this remains completely unchanged. And just in addition to that, we have an additional namespace that captures all the Ownable State data that is kept on the ledger. And so we have a subspace here, a complete subspace for all Ownable States. And for example, here we have one Ownable State that is with the identifier foo. And so basically foo is the identifier for this Ownable State subspace, and it has some metadata associated with it. That's on one hand the endorsement policy. So this is a standard public key value store pair that allows for public verifiability. So Ownable State supports public verifiability and reuses the current COP, domain-specific language that we use for endorsement policies already. Then the next field that we have are the owners. So the owners can be public or private. We'll go into details on that later on a bit more. And so this is also why they're separate from the endorsement policy. And this key essentially, also this metadata permits an owner of an ownable state to list the other owners and binds also the owners to an ownable state. It makes it perfectly clear who the owners of an ownable state are. And then the third thing that we have are the values of an ownable state. So here we have normal ledger key value store pairs. They again can be public or private. And changes to the values of an ownable state need to be endorsed according to the endorsement policy to be valid. So in this case, we have two values in this ownable state foo. So this would be foo.bar and foo.bars. And as you can see, you can even you can also reuse, for example, so since this is in a separate namespace, the keys do not clash with keys of the main the root chain code namespace. So this is completely kept separate and encapsulated. And then finally, we can also have multiple owners, of course. So here we have the ownable state foo with the values with the keys bar and bars, and then we also have the ownable state bar, which also again has the keys bar and bars. Okay. So given that, how do we create an? Yeah, sure. Please go ahead.
Can we just go back to the previous slide?
Yes.
So that means that an ownable state key is a composite key?
Yes.
Yeah.
Well,
exactly.
It's basically, yeah. It consists of multiple parts. So you could imagine you have a prefix ownable state dot foo dot value dot bar, and then you would get the value of the ownable state foo, which has with the KVS entry bar.
So the only real restriction in the original chain code namespace would be that everything that is every composite key that in this case is prefixed with OS, with the string OS, would be reserved for ownable state, and it would be okay because you couldn't have any accidental modifications because ownable state is self-endorsing, so it defines its own endorsement policy. So the chain code couldn't really affect that or mess up with that. The smartest, probably one of a good approach to do this would just be to make the OS, all the stuff in gray with in quotation marks should be configurable. So you can configure in your chain code namespace whatever the way you'd like to assemble the composite key, so that you don't affect what your chain code should use in terms of.
But what I'm asking is just so we have in the chain code API composite key support. Is that related to that, or it is just a notation? And if we do a food state OS point something, that would be translated into this ownable state. I'm just asking if we're going to need the API of the chain code that is related to composite keys.
No, I think that the proper way would be that the chain code just reasons in terms of ownable state, and then ideally the interface would be like OS dot. So you generate an ownable state, say called foo in this case. So you'd take the part on the left in this tree under OS, and then you do OS dot put state bar, and you internally the code would create the composite key, and it would do the actual put. So we should abstract this away from the chain code developer.
Can I ask a couple of more questions if you're taking questions now?
On this part, yes. Go ahead.
Right. So, and I'm guessing there will be an error message if someone needs to create a key that clashes with a prefix that you have reserved for the ownable state?
Right. So as we'll see later, any changes inside. So ownable state requires custom ESCC, VSCC, of course. It deviates from the standard one, and so the custom VSCC in this case would just verify that if we're writing into the ownable state sub namespace defined by some internal rules on how to assemble composite keys, then we would require an appropriate endorsement according to what is defined on the ledger. So in particular, in this case, say os.foo.ep, there would have to be an endorsement policy that would be modifiable only under certain circumstances, and everything same for owners, and values would be anything under values would have to be endorsed according to what's inside os.foo.ep. So the chain code could mess things up, but then either the change would be appropriately endorsed, and then you'd have to consider it a legitimate one, or it's not, and then it's an invalid transaction that everyone would reject.
Understood. This makes sense. And you had three properties describing the ownership field. I'm not sure whether you're describing these in detail later on in the presentation, in which case I can defer my questions. If not,
very much so, but just as a way to guide the conversation for now. EP contains the endorsement policy. It's public. Everyone has to understand it if they are to validate the transaction. So it has to be something, a predicate that everyone can verify. The crucial point here is that EP may reveal long-term association of long-term identities of the endorsers. So it can say org1 and org2, or it could just say public key 1 and public key 2 with no links whatsoever to the orgs, right? And so the endorsement policy may or may not reveal things, and by looking at it, you may or may not understand who the real owners are beyond just a public key or something else that's privacy preserving. And that's where the owners step in, the own concept, the own key, that it will essentially be either public or private, and it's a way for the real owners to know who they are. So if it's org1 and org2, but the endorsement policy is PK1 and PK2, org1 would know they are a member because they are, and they might wonder who the other owners are, and in this case they just look at the owners field. Yeah.
Yes, and the third subspace is just a value where you have basically the subname space for all the different values that you're going to put into the context of this ownable state.
So is there a case in which I wouldn't want to know who the other owners are? And because I noticed this was a configurable state, basically.
No, as an owner of the ownable state, you can basically always, if you're an owner yourself, the idea is that you can always read the owner field and know who the other owners are.
Exactly, and the idea is that there's a way of keeping it hidden from others. So owners will always know identities of owners because they need to be able to contact them in order to ask to endorse changes to that. Otherwise, you can't make progress. Or maybe there are more complex ways of discovering how to obtain endorsements without actually knowing who you're getting them from, but it's a much bigger topic. So we assume owners have to know about one another. The question, and we also know for sure, we're in Fabric, we have to have a public endorsement policy, otherwise people don't know how to validate transactions. And so we decouple the two so that we may have an ownable state where publicly we verify endorsement policies based on privacy-preserving tokens. Simplest instance of that would be an ephemeral public key. And so endorsement policy is something that doesn't link to long-term identities. It's not doesn't reflect who the owners are, and so you put the owners in the owner field, which in this case would be private, so you'd put it in some inside DB, for instance.
Okay, and that and this is my last question as well. I'll let you guys go on. That last bullet point there, describing the owner's field, had something to do with binding, which is, I guess, what you referred to earlier, right? A way to maintain the binding between the public keys of the endorsement policy and the actual orgs in Fabric, right?
Right, exactly. So we're still trying to say we make it ephemeral, we make it privacy preserving, but we're still in Fabric. So if you commit an action to a Fabric transaction, you will still be accountable for it one way or another. So even if you use privacy-preserving devices, we still enable an auditor to step in and request data that would link to the real owner. And so the real owner wouldn't be able to say, no, it wasn't me. I didn't do that. Somebody else did.
Understood. Thanks.
Okay. Any other questions? Okay, then I'll go on. So the next step is how do we work with ownable states? So the first step is to create an ownable state. So here we have the multiple organizations in our network. So we have green dots and we have red dots. We have the black dots here, each representing, so each color basically representing an organization in the network. And so when we create an ownable state, what we need to define first is the identifier of the ownable state, which in this case would be S, and then the organizations that we want to be owners of this ownable state. So what we first do is we set the endorsement policy of the ownable state. So on the lower right hand corner, you see here that we have the ownable state with the identifier S, and its endorsement policy requires the red organization and the green organization to sign to endorse changes to this ownable state. And this enables us in the next stage, so in phase 2, so say we then want to actually modify the ownable state because we want to write a value V into this ownable state. We can then ask those basically peers of the red and the green organization for an endorsement. And what we get back is the proposal response, and it has the read-write set that has the change to the value of the ownable state that is signed with the identities of the organization red and the organization green. And then in phase 3, we can commit the application transaction. So we can set the value K, so the key K, to the value V of this ownable state. And we present to the network the two signatures by red and green. And what happens on at the validation time essentially is that a custom validation chain code is going to pull the endorsement policy of this ownable state S. So it looks up the endorsement policy on the ledger. It sees that red and green are supposed to sign, and thus verifies that the transaction complies with this policies, that red and green have to sign off on it. And if the signatures are there, it basically the peers can commit, and otherwise it's an abort, like with every other endorsement policy. Okay, any questions to this part?
So that's like creation of an ownable state, right?
Yeah. So essentially, it's the three. So in the beginning, creating it. So where you set the endorsement policy, then the modification, how you endorse a change to the ownable state, because you want to set a value in the ownable state, and then the last part is the validation part where you actually where you submit the full transaction, which then goes through the VSCC for the validation based on the endorsement policy. So it's both the creation plus phase 2 and phase 3 actually modification. So this applies also to later changes to this ownable state.
But when I create the ownable state, I still need to get endorsement from the owners, from the future owners of the ownable state, correct?
Right. Yeah. Basically.
Yes.
So
Yeah.
Create an ownable state. You're writing into. So you say you're creating. In this case, os.s.ep. So VSCC would check, okay, there's no such key, so we're not infringing on any previously existing ownable state namespace. So if we're okay, we can create. So we'll put this key, and then we'll look for. It's kind of self-endorsed in this case because this transaction is setting its own endorsement policy because that's all you can really do at this stage. And then any future changes to this namespace will pull what this initial transaction put into the ledger and will validate transactions against that.
And there's a code called owner.
Right. Yeah. So we've sort of skipped around the owners here. Say in this case where the endorsement policy is actually not privacy preserving, you could either have no owner field whatsoever, and then you just derive the owners from the endorsement policy, and it's for public consumption, or you could just duplicate this field and say have each individual organization sign that they're really the owners. Because they were part of the initial request. So we sort of skipped on this particular detail because that really depends on which endorsement policy and which kind of crypto you'll be using here. Yeah.
Exactly, but essentially you would also set it at the beginning, together with the endorsement policy, so that all the initial owners would agree on the endorsement policy and on the owner, on the set of owners.
And transaction can span across different the endorsement. It is the union of the two policies or more policies. Is that the assumption?
Sorry, I didn't. Sort of the flapping noise. Sort of.
Yeah, the flapping, exactly.
So the transaction can span across multiple ownable state as long as the endorsement is union of all the required endorsement out there.
So we haven't really. It would be great to actually work with use case partners here. But so initially, it sounds like an end would be the most sensible approach, but there's no reason why you can't just use the full power of the existing endorsement policies and say also have all threshold gates in there. So 3 out of these 5 orgs have to endorse, or anything that's really a policy will do.
Does this answer your question?
No, what I was saying is basically, for example, in a single transaction, I can update multiple ownable state. Let's say state 1 is there, foo and var both basically, for example, that A and B, and bar is like B and C are the endorser. So if a transaction which modifies both and it's signed by A, B and C, 3, so should that be okay to assume that that's a valid transaction?
So essentially, as long as you would satisfy both the endorsement policies of all the endorsing states that you cover, then yes, in theory. However, if you modify multiple ownable states, then you're also going to, and this is basically the next part of the slide deck, then you're going to reveal that you are also that these two states are basically owned by the same parties, right? So if you have state A and you have state B, and they both occur in the same transaction, and they both get committed to the ledger, then we know that both A and B are owned by overlapping parties. So you basically you reveal additional data or like information about the ownable state that you might not want to reveal for a privacy-preserving ownable state.
Okay.
Well, exactly, and another piece to that is that essentially the ownable state can the value part of ownable state might be a piece of private data that's written on slightly B, right? And so if you have overlapping, if you require modification of multiple of those, and some are also private, you sort of you have to reveal through transient or other fields. You have to reveal all the inputs to all the endorsing parties. And if they're all the same, then you reveal that they own the same two ownable states. And if they're not the same, then you're leaking information across. So I think at the end of the day, given that it's going to be governed by custom ESCC and VSCC, we could just have sensible defaults, such as one transaction can change only one ownable state, can affect one ownable state namespace, but then it's just going to be clear on how to use the interfaces to go beyond that if it makes sense for the specific use case.
Okay, any further questions? All right, then I'll go on. So far we dealt with an endorsement policy that specifically lists basically the owners, the organization, red and green. But the really interesting part about ownable state, at least in my opinion, is privacy-preserving ownable state. So what are the privacy concerns that we might have with ownable states? So currently, when we look at, say, a transaction that wants to modify an ownable state, the first thing that we usually reveal is the transaction creator, because the transaction creator is typically like it's identified through a linkable X509-based certificate. So this we can deal with if we use IDMX rights, then we can hide the transaction creator. Then the next thing is the state content. So say we have the parties, the organizations red, green, and black, as we had before, but only red and green should actually know what the content of this ownable state is. So the default again is that the transaction read-write set is visible to all the members of the network. That is the default. But using collections, and as we will later on see how specifically local collections can help with that, we can make the read-write set that actually has the content of the ownable state private to, say, the organizations red and green. And then the final piece that we have is the endorsement phase. So here the problem that we have is that the endorsement signing identities are by default, again, linkable with regular X509-based certificates. So we know exactly who has signed and basically endorsed the change to an ownable state. And the same goes for the endorsement policies, which use linkable MSP principles by default. And here, our idea is to use essentially ephemeral credentials to have unlinkable endorsement. So what does this mean? Essentially, in the very, very first phase, when we create an ownable state, we first obtain ephemeral credentials for the endorsement of this specific ownable state. So say we create ownable state S, then as a very, very first step, we obtain ephemeral credentials. And these ephemeral credentials, so say we have again the case like before, where we want to have an ownable state with the owners red and green. They are unlinkable in the sense that we have derived credentials, in this case just the dark gray and the light gray, that we use for the whole endorsement process. So what does it look like? It's essentially it's very similar to before. it's just that in this case, when we create the ownable state S, we pass in as owners. Okay, no, actually as the endorsement policy in this case, just waiting for the flapping to stop a bit. Okay, it's better. So for the endorsement policy, we pass the the dark gray and the light gray ephemeral credentials. So nobody else in the network except for red and green knows who this dark gray and this light gray refers to. However, they know that any change to this ownable state will need to be endorsed by these using these ephemeral credentials essentially. And what we also put, this is a state that accepted, again omitted here. In this case, what we need is we need also to put the owners, and the owners in this case would be red and green, but this information would only be visible to the organizations red and green. So in the next step, when we want to modify a state, and again we want to set a value D under the key K for this ownable state S, we would go to the organizations red and green, and we know that these organizations basically own this ownable state because we have the owner field here, and we would ask them for endorsements. And in this case, the peers would not use the long-time signing identities, but these ephemeral signing identities to sign the proposal response and give it back. And now when we commit this modification transaction, we can still run the validation, and basically everyone in the network, also the black organization, can now pull again the endorsement policy that now specify, okay, dark gray and light gray have to endorse a change to this ownable state S, and verify that they so that indeed the corresponding parties, which are members of the network, but we don't know who which these members are, have signed this transaction. And if so, again, you can commit it, and if not, we abort. And so what we basically gained here is that we now have all the three parts covered, and we have so the transaction creator, if we choose to hide it, the state content, if we choose to hide it, and finally also the endorsement process. And kept all this information private, but still publicly verifiable by all organizations in the network, and not just by red and green that actually own the ownable state. Okay, questions to this part? Okay, if there's no questions to this part, I would hand over to you, Ale.
Yeah. So let me share. So I tried to share myself. Yeah. Okay. Very good. And can you see my screen?
Yes.
Okay. Okay, so just a quick detour into collections and local collections to see how this whole thing fits together. So we know very well from previous discussions that collections and SciDB are just a mechanism to achieve these two conflicting goals, apparently. So confidentiality for private data, but operating on a true blockchain. So we just don't want to petition stuff. We just want to have a public platform. So the way we solve this is on the blockchain, we just put commitments or hashes of the private data so that there's accountability later on. And at the same time, we store some nodes that are privy to the preimage, store it in a SciDB, which is not a DB that they build out of the public ledger, but they build it out of other stuff, essentially. So basically, collections, just a quick recap, they work like this. Same setting as we had before. We had, in this case, red and black collection members. We have a proposal from the user to say store data, a piece of data D. D is actually gossiped across all organizations that are members, based on the public membership that's listed in the collection configuration. Nodes know how they need to propagate. And so SciDB, that you see is a side piece of storage there of red and black nodes would store D. All other nodes would just store H on the ledger, right? Which is supposed to be the hash of D, right? The problem in this case, and especially meaningful in this context of privacy-preserving ownable state, if we want to store private data that is also part of ownable state, and we've gone to the lengths of making the ownable state privacy-preserving, so its endorsement policy doesn't leak who its owners are, but now we're using collections to hide the content of the data, but now we have the dependency that the collection itself requires a public membership. And so we're sort of defeating that particular goal. And here's where local collections step in really and help. And as we've already established in previous discussions, local collections are not really trying to replace in any way the existing collections. They're just complementing the offering, and especially to cater to this particular case, but also others. So let's see how local collections solve this problem, which is namely that now all nodes in the network know that red and black get together, and whenever they put data to that collection, it's actually red and black that are doing this. So the solution is that we split the inter-org dissemination. We force it to be proposal-driven, so it's the onus is on the client to actually reach out to every organization that is a member of that has to receive that preimage with that preimage. So you have to go through the proposal. But of course, the proposal doesn't have to leak who it was sent to. So we're good there. And then intra-org dissemination is tackled via gossip. So the client doesn't have to actually reach every single node of an org, which might create scalability problems there. And so essentially you see that we have the same distribution of the preimage as before, except now we have removed the notion of the membership of that collection from public knowledge. It's somehow known by the client, and how would be, if you use ownable state, it would be through the owners field, which always tells you one way or another who the owners are, so you know who you have to reach with your proposal to disseminate any private data that you'd like to store as part of that ownable state. And then gossip does its magic to scalably and quickly distribute the preimage within the org. And so the end game is really the same. Red and black know the preimage. Everyone else just knows the hash, except now we remove the last bit of information that was leaking information to public viewers of the channel. So how it all fits together, just a couple more slides and then we can have more questions. How it all fits together is, if we look at, this is a schematic view and simplified view of a Fabric transaction. You see we have some creator, which in vanilla instantiations just leaks, I'm a user of org1. It leaks the channel name and the chain code name, of course. Arguments are there, but from that part we are covered because anything that we want to hide from the arguments there we can put in the transient field, so that's fine. Then we have the read-write set, which if you don't use private data, it might leak private information. And then we have a list of endorsers that actually leak all the nodes that were asked to endorse that. So the sources of leakage is 1, 2, and then 3, right? Let's see what's we can prevent this leakage in an effective and secure way. Number one, through the identity mixer technology, we can change, in particular, this field here. This field here. So we have an anonymous transactor now. It's still publicly verifiable. All the its properties, that it's a member of the network, and yet you don't know of which organization and the likes. And there's support. There will be support in 1.2 for selective disclosure of attributes, so that the chain code may even be told more than what's publicly verifiable to do some chain code level access control. So that's how the first we address the first information leakage. So local collections address the second one. Collections in general and local collections in particular address the second one. So instead of having a private key that's being updated with a private value, now we have a hash of a private key that's updated with a hash of a private value. If we use vanilla collections, if we use local collections, also we don't leak who the members, who the owners of the pre-images are in that case. So there's no leakage from this perspective either. And finally, through Ownable state, like we described before, and its privacy-preserving variant, we might have a set of endorsers which are still publicly verifiable. We can still see that the transaction was properly endorsed, and yet we don't know who these nodes actually were. And so that's now, if you look at the transaction now, you can see that everything we are leaking is really so the order. So yes, we are part of an ordering network, and we're using that ordering network. So that's probably acceptable in many use cases. We are leaking who the channel name and the chain code name. We already said for arguments we don't. We have already means of hiding confidential arguments using the transient field, and everything else is sort of either anonymous or unlinkable or confidential. So that's really the big picture. Because and we thought it was useful to bring it up here, because otherwise in isolation it might have been harder to gauge the relevance and significance of the work. That's actually the last slide. So let's just pause here for any questions or doubts.
I'll ask one question. I think I know the answer, but I'll ask anyways just to make sure. So if there are two owners for an asset, these ephemeral keys, I assume there's two sets of those keys?
Right, yeah. So in the privacy-preserving Ownable state instantiation that would use ephemeral keys, the idea would be, yes, use two different ephemeral keys. So there would be an initial phase in which these keys have to be distributed across the owners, and then once that's established, then they can endorse and everyone else can verify. And if you separate, like we said before when Manish asked the question, if you separate updates to different Ownable states in different transactions, then you can really have no kind of leakage there.
And you could generate and distribute those ephemeral keys either out of band or through another chain code. Is that right?
Right. There's a lot of discussion internally on different instances. So I think the first thing would be to close on the interfaces, and then once we have interfaces on and a data model for the ledger, then we can think of particular instances. So we have come up with a bunch of them. One, for instance, would be to use SiteDB and local collections to distribute, to generate and distribute ephemeral keys. So they're placed on the ledger publicly, but only the owners have the private key corresponding to those. And so essentially key generation would be a chain code duty, key distribution would be local collection duty, and then you'd have public verifiability. There's other different approaches that use the identity mixer, others that use HSM facilities, and so I think it's going to be important to find good interfaces that don't prevent any of those from being used effectively.
So just a couple of questions. So, I mean, what I was wondering is that probably, I mean, maybe I was under wrong impression, but what I was wondering is probably cross-ownable state transactions are the main motivation. Otherwise, what we would be missing if we say that anyway you define different chain codes and transactions are limited to those chain codes, and you can define the endorsement policies for those chain codes anyway, and we are worried about the number of chain codes being
Right, yeah, so chain codes would essentially be their own endorsable and ownable namespace, in the sense that the chain code has its own endorsement policy, and the endorsement policy defines how every change to that namespace has to be validated. But that's really coarse-grained. There's good reasons to have a state within a chain code. So some portions of the state that have to be endorsed according to some rules and others according to others. And it, of course, you could split it across chain codes, but why do you have to if your data model and your processing logic fits within a chain code? If you have the liberty to express it using a more flexible endorsement policy, that might be a plus. Also, chain codes, as it stands today, are cumbersome and expensive. So they're expensive assets in terms of how they are defined and maintained, whereas ownable state is really, once you have the chain code, and then it's all a matter of sending some transactions to modify, to create a read-write set that has to be verified in some way. So it's a much cheaper, let's say, primitive to be deployed. And the fact that one transaction can only write to one ownable state, as we said before, it's not carved into the ownable state concept. It's just useful if you're thinking in terms of privacy preserving ones, but it doesn't have to be.
No, I got that part. The only thing I was saying is if you are, that probably is not going to be the most common use case, and probably mostly people would be using only updating one ownable state in one transaction. From that angle, I was thinking that if number of chain codes is the only problem, and then, for example, if we go with, let's say, system chain codes kind of thing, which are pluggable, and the same code you could always run. So instead of creating, so the equivalent to create ownable state here would be instantiate one more chain code with this endorsement policy, and it is managing its own state with those set of participants and privacy preserving and whatnot. So, I mean, the basic fundamental question in my mind is like, is manipulating multiple ownable state in single transaction not the primary use case?
Well, even if you have only one asset, you want to be able to support transfer of that asset to other parties, right? So and for that, I don't think the chain code approach would support that.
Yeah, so that is another question basically. So would it be allowed or possible to add more parties to the existing ownable state, or potentially I think you would modify the existing endorsement policy? Is that
right? Yeah. So we have. Go ahead, Matthias.
No, it's fine. I just want to say yes. So definitely changing the owners of an ownable state is also a mechanism that is going to be there, so that you can change, basically adhering to the current endorsement policy. Of course, you can change the endorsement policy, and along with it also the set of owners of an ownable state.
Yeah, I have a question. So how does that play with HSM? Because the private keys are disseminated via gossip, via all of the transient store stuff, and inside the organization between peers. But how do you get? I mean, at some point, some other peer would probably need to endorse using the private key, right? I mean, the ownable state is defined by the organization, not by the peers. So that implies that if you use HSM also for the endorsement, that implies that the private key somehow gets from the transient store of a peer to the HSM, right?
Yeah. So I think we should. So any discussion on that specific to HSMs and key management, I think we should table that, if you don't mind, to a specific session for that. I mean,
okay,
unless you think that it. No. I mean, unless you think it's a stopper for the big concept, right?
No. I was just curious. That's all.
And these local collections would be one or more collections within Ownable state, or is it a sibling to Ownable state kind of thing?
So in general, I think local collections, and there are some WIPs out there for consideration, but the idea would be it's just a collection that people define with this local flag, and whenever a peer of an org receives a pre-image, it knows that it has to propagate that pre-image only to nodes of its own organization. And so you just really need one local collection per chain code. And one might even argue that it's silly to require its creation in the first place. I mean, it's a concept that people can just use straight away. So yeah, definitely only one per chain code.
Even for the hashes to write, you would need the endorsement policies for the specific portion of it, right?
Not really. I mean, Ownable state will have its own custom ESCC and BSCC, right?
Yeah, and, so basically, it's a kind of sub-state further within Ownable state with the name of local collection.
No, I mean, the local collection, so say, you'd create a collection with the name local and the flag local as well.
Yeah, but at what level it creates? Within Ownable state or sibling to it?
Within it's a chain code. So like you create today, like you create collections today.
Okay.
So you would create a collection.
Yeah, so that's the point I think I'm missing. If you create at that level, then within local collections, you would create Ownable states?
So you know that when you create a private, when you put private data, you say put private data, name of a collection and name of a key. So when you create the chain code, you will define a collection that, say, you call local, and then you go about creating your ownable state as you do today. So the endorsement policy key will always be public because it has to be publicly known and publicly endorsable. And then once you have an ownable state, the chain code may decide to put private state into the collection that's called local, and the KVS key would be a specific one that is carved into the ownable state namespace, as we discussed earlier. Right.
So if I understand you correctly, so one key in the local collection. So first of all, there will be single local collection conceptually in the chain code, and a particular key within that might look like some prefixes of the one of the ownable states, which tells this belongs to that kind of, which matches to basically that kind of ownable state. And the further portion of the actual key is kind of hash. So it's a mix of combination of one of the identifiers for the local state plus hash of the key itself.
Right. Exactly. So if, say, in the example we had before, we had, OS, .foo, .val, .bar, that would be a public key. or you could have os.foo.val. The hash of bar as a private private key.
Basically, logically, local collection is basically collection within ownable state.
I don't see it that way. It just might be a semantic, syntactic.
Yeah, I think they're more like an orthogonal way of saying that, okay, that basically this data is private and hashed, right? This data of the ownable state. So it might be values of the ownable state, and it might be, for example, a set of owners of the ownable state. It's not public.
Right. I mean, exactly. Essentially, you would have to give more freedom to the chain code to specify or to determine what the name, the KVS name of a private key actually is. So don't always hash the full thing that I'm giving you, but give me some discretion in how I want the key name to be generated, and then you can just really think of them as orthogonal, as Matthias would say.
Any other questions?
Okay.
Yep. Well, why don't you? Well, I've heard enough slapping for the day.
Yeah. Here.
I have a question. Is there an interaction diagram that explains the flow?
Sorry. Hello? I heard the beginning of a question, but then